This can help researchers better understand how the coastal regions will be affected by rising sea levels. On the east coast of the United States, the Aerosol Cloud Meteorology Interactions over the Western Atlantic Experiment, or ACTIVATE mission, will look at how clouds in the marine boundary layer, roughly the 2 kilometers above the ocean, affect the water cycle. These cloud systems cover large stretches of the ocean and are not well represented in climate models. ACTIVATE will use 2 planes, a Falcon and a King Air, to take measurements remotely and in situ, including releasing dropsondes through the clouds. Flying the same corridor, the investigation of microphysics and precipitation for Atlantic Coast Threatening Snowstorms, or IMPACTS mission, will use measurements on the ground, scientific balloons, and 2 planes, the ER2 and the P3, to measure snowstorms at all altitudes. IMPACTS is looking closely at the intense bands of snow that form inside clouds to improve forecasting of snowstorms in the future. Stay tuned for more as these 5 missions take off.
MSOLO stands for Mass Spectrometer Observing Lunar Operations. We took an off-the-shelf mass spectrometer and worked with Enphicon to ruggedize the design to withstand the harshness of space. We bolstered the glass instrument detector, redesigned the avionics boards for better heat flow and increased radiation tolerance, and applied other standard spaceflight practices into the design. On the lunar surface, MSOLO can measure resources like water, crucial to deep space exploration, and it can measure the gases coming off a lander during touchdown. This is important so we know what is truly coming from the moon and what we brought with us. Being able to identify the lander signature will ensure we are only measuring what was already on the lunar surface. MSOLO will be sent to the moon as part of the Commercial Lunar Payload Services contract. Essentially, commercial companies are building lunar landers, and technology like ours is hitching a ride down to the surface. Not only will MSOLO help us learn more about the moon and ultimately change the way we explore our solar system, but the new rugged design we helped create is changing things down here on Earth too. By modifying an off-the-shelf mass spectrometer, NASA helped Enphicon identify ways they could improve their product that would also help universities and other researchers using their equipment in harsh environments here on Earth. In Costa Rica, investigators are flying a commercial mass spectrometer on drones over volcanoes, safely detecting what gases are being emitted. Information from volcanic plumes provides insight into what is happening inside the volcano, alerting researchers if a major eruption is imminent. We are proud of MSOLO's capabilities in space and right here on Earth. And now we're headed to the moon. From Kennedy Space Center, I'm Patricia Valendia.
When it opens its eyes to our universe in the mid-2020s, WFIRST, the Wide Field Infrared Survey Telescope, will capture images unlike any satellite before it. WFIRST will have the same image resolution as Hubble, but will cover an area 100 times larger. WFIRST will also view the sky in carefully selected wavelengths of infrared light, which will allow it to see through obscuring dust, to reveal hidden stars, and watch the growth of galaxies over the last 10 billion years. To see what the sky will look like to WFIRST, scientists use special processing techniques to create simulated images. In this case, they began with a Hubble mosaic of Andromeda, one of the closest galaxies to our own. Released in 2015, this mosaic was created out of over 400 individual Hubble images and took more than 3 years. Because of its enormous coverage, WFIRST will be able to create a similar mosaic with just 2 images, each taking about 90 minutes. WFIRST images are actually made of 18 separate panels, each one corresponding to a single 16-megapixel detector. The arrangement of these detectors creates the distinctive WFIRST image shape. The simulated image is not just special because of its size, however. It also shows Andromeda as it will appear through WFIRST's optics and infrared filters. To achieve this, scientists started with Hubble filters that are closest to WFIRST's. Then, they used software to measure the positions and brightnesses of the roughly 100 million stars in those images and applied those as input to WFIRST image simulation software, which added each star back to the image after applying the expected effects of the WFIRST optics, filters, and detectors. The resulting image reveals many stars that were blocked by dust in visible light. It highlights WFIRST's role in providing a more comprehensive view of the stars in the local universe. WFIRST will also use its broad view to search for planets around other stars in our galaxy, and to look for the fingerprint of dark matter and dark energy in the distant reaches of the universe. With an unprecedented combination of breadth and depth, WFIRST will open a new era in viewing our universe.
They are the best of the best. They represent the best of humanity and our most fervent hopes for the future. No pressure.
Folks used to tell kids when I was growing up, reach for the moon. But that's not the objective anymore. Now we've got to revise it to reach for Mars.
And what I'm so excited going forward with Artemis is that when the next astronaut lands on the moon, maybe one of these men and women, and by the way, as the father of 2 daughters, I could not be more excited that we will land a woman on the moon and bring her home safely.
Hi, I'm Jacob Bleacher. I'm a geologist. That means I study rocks and dirt on the Earth and planets. This is Ask NASA. I'm here to answer your questions. What is unique about the surface of the moon? Well, the moon is quite unique from the Earth. It has no atmosphere. There's no air to breathe. What that means is that the processes that have occurred on the moon are all preserved there in the rocks. For instance, if you look at the moon from the Earth, you may see circles. Those circles are impact craters. Let me show you. Except, making craters is really dirty business. I need my crater making poncho. Now we're ready. Let's pretend this is the surface of the moon. It looks a lot like this. That's one crater, but the surface of the moon has many more.
Oh, that was a good one.
On the moon, these craters have formed over time, and as you saw, material from each crater buries the previous ones, making this very rough terrain. In that terrain, at the pole, there are some craters that we believe have water ice trapped there, and they never see the sunlight. That's good for science, and could also be a resource that helps our astronauts survive. Why study moon rocks? Well, besides the fact that rocks are awesome, each rock is kind of like a person. It has its own fingerprint. We talked about impact craters. That's recorded in the rocks. Whether or not ice or water has been near there, that's recorded in the rocks. It tells us the history of the moon. What tools will astronauts use to explore the moon? Well, hopefully we'll have plenty of tools for them. For instance, something like this. This is a hammer like you would use here on Earth. It's a geologist's best friend. It helps us to break up rocks and select samples. You could also use things like rakes and shovels to help us find the right kind of material to bring home. Eventually, we could be using tools more like this. This tool is an X-ray fluorescence spectrometer, or XRF. An XRF basically shoots X-rays at a rock and then detects what comes back. And as I talked about before, rocks have unique fingerprints. This helps us to determine what that fingerprint is. Our astronauts will also use rovers, like this model that you can see right here. These vehicles are designed so that they can help us move around on the surface. Well, this tool is 3D printed, but this is just a model of an XRF. But right now, we're actually testing 3D printers in space on the International Space Station. It'd be really helpful if we can use 3D printers to design the tools that we need. How are we preparing astronauts to investigate the moon's surface? Well, we have to practice here on Earth. The way we do that is we talk to them in laboratory and classrooms, and we also take them out into the field, places like Hawaii or Iceland or Arizona. Places where there are similarities to what they might experience on the lunar surface. We're really excited to send humans to the moon with the Artemis program. The first woman and the next man will be going back there by 2024. Together, they'll be able to explore the surface of the moon. Well, right now our plan is to send crew to the surface of the moon once per year and bring more supplies to the surface so that we can explore more and more of the South Polar region. That is a great question. The first thing that's going to be very different is that during Apollo, the sun was overhead. But at the South Pole, the sun is always going to be right on the horizon. That means we'll have really long shadows and areas that are very dark. It's going to be very different. We really are exploring a brand new terrain where no one has ever been. The studies we'll be trying to do are looking at and understanding perhaps the water cycle on the moon. And we really want to understand the processes that lead to that water being preserved there. Ooh, that's an intriguing question. First of all, we can see fairly deep into the interior of the moon by looking into craters. That's kind of our natural laboratory for getting at the inside of the crater. Every time a crater forms, there's an explosion that moves rock up and out from inside of the moon. So our astronauts walking around the rim of the craters can pick up rocks that came from deep inside. The bigger the crater, the deeper the rocks. Well, in fact, we are aiming for farther out. Eventually, we want to get to Mars. But first, we're going to go to the moon and learn some really important answers to questions that will help us survive the trip out to Mars here, because I guarantee you I'm going to have a lot of questions for them when they get back.
Do you have a question for NASA? Send your questions to our experts using hashtag AskNASA.
They are the best of the best. They represent the best of humanity and our most fervent hopes for the future. No pressure.
Folks used to tell kids when I was growing up, reach for the moon. But that's not the objective anymore. Now we've got to revise it to reach for Mars.
And what I'm so excited going forward with Artemis is that when the next astronaut lands on the moon, maybe one of these men and women, and by the way, as the father of 2 daughters, I could not be more excited that we will land a woman on the moon and bring her home safely.
And as we leave the moon, we leave as we came, and God willing, as we shall return.
You probably dreamed of this.
Liftoff on Apollo 11.
You probably replayed this moment 1,000 times. You probably imagined the awe-inspiring, indescribable rush of the ride. You probably celebrated the miraculous, cheered the momentous, and mourned the shocking. You probably still dream of what could be. We did. We do. And while many thought we were through, no. We've been learning, we've been building, we've been training. And now, it's time. Because the next frontier is not just for the next generation. It's for this generation. It's for me, and it's for you. For everything we still dream about. We go as Artemis.
Hey, how are you doing?
My name's Naomi Akin.
And my name's Kelly Marie Tran. And we're at NASA's Johnson Space Center.
And we're training to be astronauts.
No big deal. No big deal at all. We got this.
Come on, let us do it.
Let's go.
The first thing we're going to show you this morning is what's called a gravity offload system. So people often think that we have a room here where you can go in and flip a switch and suddenly you're floating. That's not really how it works.
You want to see how it works when you're 1/6 your weight or 3/8 your weight. We use Argos to do that. And then we use it to work on like new tools, new geology, sampling procedures. So from here, what we do, we'll lift you up off the ground.
Oh my God!
And we'll put you into lunar gravity.
What is that?
All right, so this right here is zero gravity. So if you were on a space station and I were to push you and say, see ya, you're just gonna put it away I push you.
I realize now why astronauts walk like this.
Yeah!
Because everyone's just like trying as much as possible.
Do you guys want to go check out the suits?
Yeah.
Want to go try some on? Alright.
Yeah.
Next.
So we're going to talk to you a little bit about spacesuits today. We're going to move some suits over here, I think, real quick, and we'll talk to you a little bit about what they are, and then we're going to let you guys change and actually try some out.
So you go out there and there's no air. So then there's pressure pushing in on your body?
So what we would have to go through is your body would want to expand out, so that's why we wear a suit around us that goes through and creates an artificial atmosphere.
Do you guys have training in terms of how quickly you can get in and out of these? Is that a thing or not?
No, I mean you have to know your spacesuit really well, but we don't do drills like getting in them quickly. You typically are helping each other, getting into and out of them when you're in space.
And so those tubes actually are going to carry cold water, help us cool. We'll see what that feels like once we get inside. But these guys are going to help you climb into the suits.
Yeah, like Chewie.
With the guy who plays Chewbacca.
Really? Stand up.
Well, unfortunately, we're going to get you guys out of the suit now, but then we're going to take you over and see the vehicle that you would be in these suits in. Okay. In the Orion vehicle.
This is the Space Launch System. This is what's going to push this capsule. This is the Artemis 1. This is going to go to the moon about 1 year from now.
Yes. Awesome. Oh my gosh. Yes. Okay. 9 and 9 it. Yeah.
This is the docking hatch up here. When we get to the gateway, we will dock at that port, and there will be a hatch up there that we open to go into the gateway.
Which you have to like target, right? So you have to like figure out a way to drive the rocket so that the holes match up.
Yeah, we actually make the switches, it's a multi-step so you don't accidentally hit a switch.
We're gonna go check out the mock-ups for the space station, which will seem luxuriously large. Okay. This gives you an idea of how big of a room each person is. So you can put up, your space.
So yeah, you do. You have a sleeping bag, as they mentioned, and you can pin that to the wall, and you can float kind of inside your sleeping bag. You can tighten it down if you would like to feel a little bit more stable.
This is Houston. Yes.
This is when they actually say Houston, we have a problem. This is Houston.
So that's live.
They're in space right now. What are they doing? Oh my gosh, this is mad.
What's the day-to-day like in this room?
Yeah.
So in this room we have 3 shifts a day. My favorite shift is the night shift because it's when nobody's in this building but we get to hang out with the crew.
Are you guys ready to try some space food?
Yes.
That's next on the list.
Where do you get the suggestions of what to work on next?
That's a great question. We get a lot from the crew office, or the crew office says, can we move away from red meat and potatoes and get Brussels sprouts, butternut squash? And this comes from a lot of crew comments as well as input from the nutrition line here at JSC that says, you guys should probably go with the salty. So on station, the astronauts have a much more advanced dehydration apparatus. They have the potable water dispenser. The astronauts can help you with figuring out how to unlock the straw.
Release this spring.
Because otherwise,
so that way when you set it down, liquid's not going to come up on the
Stuff is at the bottom, so you want to like do
she knows the tricks of the trade.
Yeah. Which one is your favorite? I would say the butternut squash is my favorite. But I like things that are sweet.
I like the Brussels sprouts, I think. They're so good.
All right, well, you guys have had your afternoon snack. Now you ready to go drive a lunar rover? All right, let's go check it out.
I really don't know how to drive. This is like going to be a teacher.
Oh,
What is that? Oh, is it here? Ooh,
it's air conditioning.
It's air conditioned?
Twist.
Yep.
This is so cool.
On the lunar surface, it'll basically be, you're in the rover, like Megan and Jessica will be in the rover for up to 14 days living together. And there'll be another rover, they'll go out for 14 days and explore. And if one breaks down, all 4 of you will jump in one vehicle.
I think I made contact. I think we're there.
Awesome.
We're there.
Yeah. That was smooth.
That was awesome.
Do
Dude, what an amazing day. It's been really good.
It's been amazing. It's more than I expected.
Yeah.
I have so much respect for NASA. Yeah. Thank you for bringing us
NASA.
here.
Welcome. Welcome to the James Webb Auditorium at NASA headquarters. Today we have really an amazing celebration. We are celebrating a name change of a mission that is not just critically important to NASA, but to our partners here in the United States, NOAA, and of course our partners all over the world, as a matter of fact. This is a mission critical, not just to the United States, but to the whole world. So we're going to rename it. But we also have the opportunity today to celebrate an amazing career of one of the NASA family, Mike Freilich. And a lot of you in this room know Mike Freilich very personally. He was the head of the Earth Science Division of the Science Mission Directorate, and he did an absolutely magnificent job running that division. I will tell you, I got to know him very personally as the NASA administrator on a number of occasions, and I'll talk about that in a few minutes. I first want to start by welcoming some of the international partners that are here in this room that came to the NASA headquarters on behalf of this celebration. And that is very meaningful that you would come all the way across the pond for this. The first one I'd like to introduce is Dr. Joseph Oshbacher. He is the Director of Earth Observation Programs at the European Space Agency. Mr. Alain Rodier, he's the Director General of EUMETSAT. Ms. Mercedes Garcia Perez, the Head of Global Issues and Innovation of the European Union Delegation to the United States of America. Dr. Stephen Volz, NOAA Assistant Administrator for Satellite and Information Services. And of course, we have with us today the Associate Administrator of Science for NASA, Dr. Thomas Zurbuchen. So today is a celebration of a naming of the Sentinel-6 satellite. It's also, which is a critical component of the Copernicus program, which is really a global initiative to understand how our Earth is changing, but it's also a celebration of Dr. Mike Freilich and his amazing contributions, not just to this particular satellite, but to the whole host of missions that NASA does within the Earth Science Division. Here's what we know. We know that the Earth is changing constantly. We know that carbon dioxide is a big reason for that change. We know that humans have put more of it into the atmosphere than ever before, and therefore we are responsible, at least in part, for the warming that we're seeing. We also know that NASA has a unique perspective. that we can understand feedback mechanisms. I should say we don't yet, but we're learning how to understand feedback mechanisms. When the Earth warms, we see the Arctic ice melting, and when the Arctic ice melts, it has huge impacts for the environment as well. We see the warming when a lot of the energy from the sun is absorbed into the darker ocean rather than reflected by the ice. That creates a feedback mechanism. We know that when the Earth greens because of the increased carbon dioxide in the atmosphere, we know that that also has a feedback mechanism that is delayed, but it's the opposite direction. It has a cooling effect. So here's what we know. We know that there is a whole lot more to learn about each of the systems that comprise the entirety of the Earth: the lithosphere, the atmosphere, the hydrosphere. And of course, Dr. Mike Freilich has been at the very center of all of these activities. One of my first interactions with him when I became the NASA administrator, I got invited to participate in what was called, it was the Global Ag Summit. It was out in Tulare, California. And I called Dr. Mike Freilich and I said, hey, I need to give a speech on how earth science is affecting ag. What is NASA doing to feed more of the world than ever before? And of course, he came up and he shared with me a whole host of different mission sets that are critical to increasing the capability of feeding more of the world than ever before. And of course, he ran the whole Earth Science Division, but there was a number of missions that were very near and dear to his heart. The Copernicus program is one of those. I wasn't the head of the agency at the time, but I have heard from many, many people that he was a driving force behind a lot of these activities that became this global initiative to understand our changing Earth and ultimately help decision makers make good decisions as it continues to change. So with that, what I'd like to do is show a quick video that demonstrates what Sentinel-6 is, who all is involved, and what we can expect from it in the future.
Ottobrunn, Germany. At this IAGB cleanroom, Sentinel-6 is ready for final testing, after which the satellite will be shipped to the US for launch in 2020. Like all the Sentinel satellites, Sentinel-6 is part of the European Union's Copernicus program. But for this satellite, ESA and the EU have joined forces with a number of other partners, such as EUMETSAT, NASA and NOAA, benefiting from each other's expertise. The Sentinel-6 mission will consist of 2 identical satellites that are launched sequentially. They each carry a radar altimeter to provide high-precision measurements of ocean topography on a global scale. At an orbit altitude of around 1,300 kilometers, Sentinel-6's lifespan is limited to 5 years. But by flying both satellites consecutively, the mission will provide data for over a decade. It will continue the long-term data sets on sea surface height that have been gathered since the 1990s by the French TOPEX Poseidon and the Jason missions. It is crucial to continue these measurements for climate research, as they offer insight into the causes and effects of sea level rise. With water covering 2/3 of our planet, monitoring our oceans with Sentinel-6 from space is a necessity.
Take a moment and look at those agencies that are involved in Sentinel-6. There's a lot. And I can tell you as the head of NASA, it's really hard to get anything through the bureaucracy. I don't know if any of you have noticed that. Mike certainly has not noticed that because he gets things through the bureaucracy. But getting anything through the bureaucracy of any big government agency like NASA, like NOAA, is difficult. But here we have this amazing program with support from the entire world. And it not just got through our bureaucracy, it got through the NOAA bureaucracy, it got through the European Commission, the European Space Agency, EUMETSAT, of course, dealing with Congress, dealing with politicians in general. I can say that because I used to be one. It's sometimes difficult. But these programs are important. And if you believe in them, you push for them. And all the roadblocks that come in your way, you get those roadblocks gone and you keep moving forward. That's what Mike Freilich did in helping move these programs forward in a meaningful way. And I just want to say we're grateful for your service. And I want to say to the folks that are here on the front row, you guys have all been champions of this. And he couldn't have done it without your help, but you couldn't have done it without his help. And that's why this is such a meaningful long-term program. So getting through one bureaucracy is tough. Dealing with all of the bureaucracies, not just in our own country, but countries around the world, is even tougher. And it's an amazing tribute to what you've been able to accomplish as the head of the Earth Science Division, Dr. Mike Freilich. So with that, I'd like to bring up our next speaker, Dr. Joseph Oshbacher. He's the Director of Earth Observation Programs at the European Space Agency. Thank you for being here.
Thank you, Jim. Ladies and gentlemen, dear friends. It is a very special moment to be here, and I really appreciate the very kind words said by NASA Administrator Jim Bridenstine on the good cooperation we have between Europe and the United States, because this is a very special moment. It's a very emotional moment, and I'm very pleased and very honored at this moment to announce the renaming of Sentinel-6, which is a joint European-US mission within the Copernicus program, but with a very strong American contribution, which is equal to that of Europe. I'm very pleased to rename Sentinel-6A in the future to be called Sentinel-6 Michael Freilich. I'm very honored to do this renaming on behalf of not only myself, but many of us in Europe. Of the ESA member states, I've consulted 22 of our member states, which we have, and they agree, and they send their regards and best wishes. I've also closely coordinated, obviously, with the European Commission in Brussels. We have a representative here today, and with Ella Ratier, EUMETSAT, who is also speaking later on. And this is really coming from all our heart. It is to you, Mike, for what you have done in order to make Sentinel-6 happen. I really would like to underline that Sentinel-6 would not exist without Mike Freilich's contribution. Mike has been instrumental in ring-fencing, in making sure that the US contribution is materializing and is coming over the many years such a program preparation takes. On our side, and as Jim was saying, it takes a long time and a lot of effort to get programs through the various administrations, and believe me, in Europe with 22 countries on the ESA side and 28 on the European Union side, it's by far not easier than here in the US. We have our hurdles to take, but one pillar, one constant element of this collaboration was always that we can trust America, that we can trust US contribution to come, and this through the person of Mike Freilich, who was making sure that US contribution is coming and is being delivered. And this is being shown right now with the finalization of the satellite. We have seen before in the video that we're at the final stage. We had a very important event in close to Munich where the satellite was shown to the press, and we will launch it later this year from US Seoul with a US launcher, thanks to the contribution of the United States of America. We have been working with Mike and with NASA Earth Science for many, many years, decades. It goes back actually that we have been working together with NASA to the 80s. But in 2010, we established what is called the Joint Program Planning Group, which is a formal mechanism where we meet formally once a year to exchange our experience, to establish cooperation topics and cooperation activities. And Mike and my predecessor, and now myself, have been instrumental in making sure this is happening. We have been addressing different topics, missions and technology, calibration, validation, field campaigns, but also access to data, exchange of data in many domains. Let me just mention a few of them, because they are all important: gravity, soil moisture, sea ice volume, sea surface salinity, ice sheet volume and mass change, Greenland ice loss, land cover, and many, many other topics where we have been working together for really many, many years. And I think it is a very historic moment also, because on our side, the European side, the Copernicus program is maturing, and we have launched a few satellites. We are launching a very important one towards the end of the year, but we are also entering into the next phase of Copernicus. We have had a very important and successful ministerial conference in November last year, and we got new money, new commitments from our member states, from our politicians, to start the next phase and the expansion of the Copernicus program. And I would like to do that again with America. We have some ideas in the making. We are in discussion on some concrete missions, on some concrete activities, and I hope that we continue this strong cooperation which we have been initiating through Sentinel-6 as one example. And this is really something that makes me very proud, that we have been able to work together. Mike has been a driving force in doing that. Mike has been extremely gentle, nice, and strong in this cooperation with America, with Europe as an American strong partner, but also with other partners outside these two nations or these two blocs, actually at the global level. And Mike has also reinforced NASA's standing in the national sphere through CEOS. When Mike came on board, CEOS was reinforced and really got a much stronger visibility and much more force than it was ever before. So Mike, we really owe you a lot. Also in ESA, you have taught us a lot. NASA is always a big example for us to follow. We always very carefully watch and see what is happening and how you're doing it, and we have learned a lot from you, and I thank you for all the lessons and all the elements you have been teaching us directly and indirectly, and this is very much appreciated. So I'm here really to convey these thanks on behalf of a large community, and I would like to also personally thank you as a friend, as a colleague, but not only myself. I have announced, of course, that I'm coming here to this occasion, and many of my colleagues in ESA, but also in our member states, have asked me to convey their greetings to you through me and making sure that they are reaching you. And I really would like to say, on behalf of all our colleagues in ESA Earth Observation and many other colleagues in ESA, thank you very much for what you have done over the last few years. This is really a small gesture which we can do in order to honor you and honor your contribution to us. Thank you very much, Mike.
I was so excited to receive a letter by the European Space Agency and the European Commission proposing that Sentinel-6A should be Sentinel-6 Mike Freilich.
Having a satellite named after you is pretty remarkable. It's not something we do in earth science very often.
It's not only ESA, it's Europe who wishes to honor Mike Freilich.
Mike Freilich has been instrumental in making Sentinel-6 a satellite that measures with very high precision sea level rise.
The Sentinel missions are something that Mike was very involved in.
It really epitomizes the role that Mike has played over the years as championing partnerships, championing collaborative investigation of the Earth.
Names are reserved for the greats. You don't name after a satellite after somebody who just does their job.
It's the second mission ever named after a person who's alive. It's a huge honor, and I couldn't be more excited.
Through this, we want to pay tribute to a unique cooperation between the US and Europe and a unique personality, Mike Freilich.
Dr. Mike Freilich is a world-renowned ocean scientist who, after a successful career in academia, came to NASA and for 12 years led all of Earth science.
And he's really brought NASA back on the international stage.
The partnerships that we forge are beyond a business transaction. They are about friendship, and Mike did just that.
Working with our international partners, working with our interagency partners.
And Mike brought that community together in a way that was really unprecedented.
Mike Freilich's legacy is being able to build the coalitions that are necessary for us to get as much understanding of our planet as possible. There is not another person more deserving of this honor than Mike Freilich. You know, when I first found out that Mike had cancer, I got a call from Thomas Zurbuchen.
So I called up the administrator and told him about it immediately.
And he shared with me kind of what was going on. And I asked him, I said, we've got to do something quickly. I want him to know that all the work he's done is extremely meaningful.
Mike is a leader to all of us and a mentor and a person who has really advanced earth science for the entire world.
What is unique with Mike is his commitment to science and cooperation, but also his resilience and sense of humor. And I believe these are two facets of the same coin.
Is unapologetically excellent.
I am much better because of what I learned from him and because I had the opportunity to work with him.
It's just been very rewarding, not just for me, but for the people in my organization to have had the privilege, really, of being his colleague and friend.
He was absolutely committed to dispassionately following the science.
He had high standards for himself and everyone around him.
Mike had a very big, very full red pen. Everybody was always afraid of that red pen.
His pretty intense energy. One of the characteristics was the bouncing knee, which you never missed, and it was always there, and you could kind of gauge the way the meeting was going by the pace of the bounce.
I have a lot of hilarious emails on my smartphone exchange with Mike, which I keep as a treasure.
And thank you, Mike, for being such a wonderful partner, a trusted partner who has built up this relationship over many years. Without you, Mike, or without Mike Freilich, this would not have happened.
It is a no-brainer that we all came together and that they were able to really rally around and allow the renaming of Sentinel-6A after Mike.
When I got that letter, the first thing I did is, frankly, I called Mike and said, I received this letter. It would be an honor for all of us if we could name that spacecraft after you. Would you accept that? And he said, I'll be selfish, absolutely.
I knew in 10th grade that I wanted to be a nearshore oceanographer. What has driven me is understanding how nature works. I got a call from Dr. Jack Kay here at NASA headquarters asking me whether I might be interested in running the Earth Science Division here at NASA. We made dramatic progress in the last 13 years with our really substantive mission and analysis international collaborations to bring together people who have expertise in many different disciplines to work for long periods of time on problems that none of them individually could solve, but together could. Earth system science is bigger than any particular agency. It's bigger than any single nation. It's bigger than any single continent. And I surely hope, because humanity requires it, that we make some significant progress in understanding.
We all see that Mike is a very special person, and allow me to hand over a small gift to you, or two small gifts, which my colleagues asked me to bring to the United States. One of them is a model of Sentinel-6, now called Sentinel-6 Michael Freilich. We have to change the engraving. And one is a small box here, which Mike will unwrap back home, I assume. And this comes from our project team in ESTEC. Guido Leverini and the Sentinel-6 project managers, they heard that I'm going here. And they stopped me on the way out when I was there last week. And they said, Joseph, we hear you're going to the US to meet Mike Freilich, and there's this ceremony. Could you please hand over a small personal gift from us, because we really miss him, we appreciate his work, and this comes from Guido, Pierrick, and all his team. Thank you. And now it is my pleasure and also honor to introduce and to ask Dr. Thomas Surbuchen to come on stage, Associate Administrator of the Science Mission Directorate. Thomas, please.
Thank you, Josef, and thanks for your friendship, as expressed through this generous action that came from you and your colleagues all over Europe. We're, of course, here at NASA in an agency that seeks, like no other agency, to leave this planet. We're going to places, to the moon. We want to go to Mars with humans. We want to send missions that look at the vastness of space, at other planets, explore places that we've never seen. But what's really exciting, and one of the benefits of working here, I've talked to many individuals who've been in space. When they're in space, they tell me, the most impressive part is to look back. Is to look back at our Earth that has been from the beginning part of what NASA does, investigating it, understanding the most complex planet we know, and at this moment in time, the only planet where there's life. A planet that is so beautiful that my astronaut friends tell me takes their breath away, because what they think about is that their entire history and all their hope about the future is on this celestial body that looks so incredibly beautiful, a complex system of systems of the type the administrator talked about, a system that we've learned a lot about in the last decades of science, but a system that yet hides a lot of secrets, a system that has all the future and hopes of our children and our children's children's right in it, and a system that we investigate as partners. Mike has been a hero for all of us of investigating that very planet. Scientists that brought to work each and every day the discipline that it takes to analyze our planet with the tools of science. Science is very unforgiving, it turns out, very humbling. Most of the time, we don't talk about that very often, most of the time when we do science, we're wrong for the first 5 times before we get it right. Being a scientist means you bounce back from that. We learn, we question, every question is okay. We answer those questions with the tools that we get from our satellites, with data. That's how we're advancing, and sometimes get surprised by, in fact, what the planet is telling us about how it works and about the future. Now, studying in partnership, in true partnership, not only domestically, which is one of the paradigms that Mike brought to work, with NOAA, with our cross-agency partners, but also with our international partners, has been something that Mike stood from the beginning. I too remember some of the first meetings with Mike where he told me how important it is to take those partnerships seriously. And I really believe, just like he does, that what we're seeing here, a true partnership built on genuine interest, genuine alignment of values, and genuine desire to actually help our population get a better understanding, take that understanding and protect and improve life on Earth. That kind of partnership is what is being manifested here today. What I'm going to say next has everything to do with the personal level of that. There's very few times during my work here I'm tearing up. When I got that email from Josef and his European partners was one of those moments. Because you can't talk more about friendship. You cannot talk more about trust than coming to your cross-agency partner and your international partner and naming your spacecraft that was conceived initially, of course, in Europe after your international colleague. That has, my friends, has never occurred in history. In history of this agency and any other agency. In fact, this is only the second time where a mission is named after a person who sees that naming ceremony. I'm just so excited that you're right here with us. But what I'm just so excited about is what this letter said, what this event today says about the hope and the optimism of us coming together and doing the right thing in partnership to really advance the understanding of this planet and recommit to the very values that Mike stood for his entire career here, that I learned from, that many of us learned from, and that we're committing our careers, our lives to continue in his legacy. I could not be more excited to be here today. And I'm so excited now to introduce one of those international partners, Mercedes Garcia Perez, the head of global issues of the European Union delegation. Thank you so much.
Thank you, Dr. Zurbuchen. It is a great pleasure and a real honor to represent the European Commission and the entire European Union at the renaming of the Sentinel-6A satellite to honor Dr. Mike Freilich. Sentinel-6 is essential to the mission of Copernicus, and Copernicus is essential to the future of humanity. This is no exaggeration. Copernicus is a factor of change to address the greatest challenges humanity is faced with: climate change and environmental degradation. We need Copernicus as a tool for accurate diagnosis. And in the case of this satellite, it's about sea level rise. We need Copernicus as a tool for monitoring the effectiveness of the remedies we apply. We need it as a tool to identify new threats, and because we need all the data we can gather to understand better our planet. But as it has been explained before, we cannot do this alone because it is a global challenge. We need to work together, and indeed together is the key word, because working together is Dr. Freilich's way of doing things. It is therefore only fair that the Sentinel-6 satellite is now named Sentinel-6 Michael Freilich. It is a gesture of friendship and a celebration of our joint cooperation. Dr. Freilich, you have been instrumental in enabling this mission through significant contributions from NASA. You led us in showing how our organizations can work together on shared projects and objectives, despite our challenges and our differences. You created a space where collaboration can grow, and you nurtured it, you nourished it so that it could flourish. And this is the result today. We're so grateful. And this is not all. You also changed the discipline of earth science in a profound way, combining science and technology to understand our beautiful planet. You did good, Dr. Freilich, for all of us, and for that we're all very grateful. Let me now hand over to Dr. Silvolds, NOAA's Assistant Administrator for Satellite and Information Services.
Thank you, Madam Garcia Perez, for that introduction and for your words. It's really an honor and a privilege to be here with friends and colleagues to pay tribute to Michael Freilich's career, his significant contributions to Earth science and satellite altimetry specifically. ESA, the Commission, and EUMETSAT's generous decision to rename the satellite is a suitable recognition of Dr. Freilich's career and lifetime of contributions, not just to altimetry, but to Earth science in general and the collective objective that we all have. You heard about the importance of this mission from climate, sea level rise, and the like. From the NOAA perspective, and I imagine from EUMETSAT perspective as well, it's not just what's happening years from now as the sea level rise, but we use the information from the satellite daily as we might monitor storms and how hurricanes are formed and how they're created. So the impact of these missions, and this and many others, is not just in understanding the planet, but it's actually adapting to it and mitigating the impacts of the weather and the events that occur on this planet. So it is a set of data and information that is used daily and by all of us around the planet, and we all benefit from this. But I would say at the center of today's discussion is about partnerships and about joint ventures. And Jim Bridenstine opened up the conversation talking about how bureaucracies are difficult to work with and work through. I'll give you a different perspective. Bureaucracies are what make this possible. This mission and the others we do, which involve billions and billions of euros and dollars, could never be done by an individual with an idea. They're done by a collective, by a community of people with a common idea, and it takes work to get those communities to work together. All of us, and Michael in particular, understood the trust that we had to use citizens' money to invest in Earth understandings and Earth observations. So the bureaucracy was not an enemy, but a tool. It was a mechanism that which we had to work. When Dr. K asked Mike, was he willing to come here, it wasn't a question, is the bureaucracy good or bad, is can I have an impact? And Mike came in with a message and a mission to have an impact, to make a difference, and using and working with the people he had with us here. And I think it goes without saying that having worked with Mike for 12 years here at Earth Science and as I'm over at NOAA, he has the ability to make a change, to upgrade the performance of every group he works with. And that's in a very singular, Freilich way. It's not coming in and telling everybody what they're doing wrong or how they can do it better. It's coming in and adding value to the mission, adding value to the conversation, asking the right questions that sometimes we look at and ignore or we don't even realize are there, asking how and why we're doing something in a particular way and how we can do it better, with the we as the operative part here. And I'll give one specific example. Mike sat through hundreds and hundreds of Program Management Council meetings here in science, in NASA, the Science Directorate. Maybe a quarter of those were Earth science, the others were astrophysics, planetary science, and the like. And in every one of those, he participated. He made everybody else start to ask those same questions. He made it was not about personal performance, but it was about what are we trying to achieve. And I think in that role here and in other areas, we're able to raise the bar of what we can expect from ourselves, from our partners, and from our own and from our larger global community, and which is where the global part was really the essential part that Mike brought in. So I'll end with a personal note. Mike, the characterization of helping the group work better was epitomized by observation, the mentoring task Mike gave me once. He said, never ask for information you're not going to do something with. Don't ask for something just because you can, just because it's interesting. Understand that in asking a question, you're asking somebody else to do a lot of work. And that definitely happens in a position of power, which Mike had, and I've learned in the one I have. You don't ask for something for interest, you ask because you need it. It's necessary and it's essential. Now, why is that important? The message that sends back is, I'm respectful of other people's time and effort. I don't do something because I can. I do something because it's important and it's necessary. And that was the message Mike constantly brought across. We were doing this for a greater purpose, not just to aggrandize a particular organization, a particular mission, but because the mission is part of a whole, which is necessary for all of us to thrive. And I appreciate, Mike, your mentoring and teaching so we can do that. I think it really is an epitome to Mike's character and his contributions. It is respectful of mission and of people, respectful of the purpose, and an understanding of the greater goal, which we only accomplish by working well together. So, Mike, you've done that, and this tribute here is a testimony to what that's been able to do and what we will continue to follow through with as we've learned from you. And with that, I'd like to introduce Dr. Alain Ratier, the Director General of EUMETSAT, my partner in weather and Earth observations. Thank you.
Thank you, Steve. I think our presence today reflects our commitment to a long-standing and very special partnership for ocean and sea level monitoring. NASA and CNES started with the TOPEX Poseidon and JASON missions. EUMETSAT and NOAA joined with JASON 2. The European Commission joined with JASON 3. It's not known, but it's true. And ESA with Sentinel-6 taking the lead on the satellite development. And today, we all stand as one. This is a very special partnership, and it started under the best transatlantic auspices. Believe it or not, but the JASON program was approved by the CNES Board of Governors on the 4th of July. This was a prediction. I remember we were close to renaming TOPEX Poseidon. The name of Laplace, a famous French scientist who put ocean tides into equations, emerged. But it sounded a bit too French, and nobody had met Laplace. So this time, it was much easier to rename our next satellite Sentinel-6 Michael Freilich, even if the European Commission, ESA, and EUMETSAT had to agree on the Copernicus side. And yes, Jim, we did not need an MOU. This time we had no bureaucracy, because we all wish to communicate the value and resilience of our transatlantic cooperation and pay tribute to the unique personality of Mike Freilich. Mike Freilich's commitment to Earth system science with no borders and to cooperation is unrivaled. And we in Europe are delighted to honor a true American who is also a citizen of the world. This is the best introduction I found for Dr. Michael Freilich, but I'm sure he will introduce himself much better than I could. Mike.
Well, thanks. If I'm going to do my 45-minute lecture on altimetry, we have to get going. Seriously, I'm more than humbled by this great honor. Thank you so much from the bottom of my heart. Now, decadal scale trends in regional and global sea level are perhaps the most robust evidence that Earth's climate is changing. And that's why humanity, not one agency, not one country, not one continent, but why humanity has been monitoring global sea level from space with exquisite accuracy for more than 28 years. Like the Sentinel-6 missions that we've heard about today, each one of the previous precision nadir altimetry missions has involved essential international collaboration between European and US agencies. And based on my research at least, if you take all the altimeter missions together, the continuous altimeter mission set represents the longest and most successful multinational and intercontinental collaborative Earth remote sensing program that our species has achieved. That is an accomplishment. As we've evolved our instrument and our spacecraft designs, so too have we strengthened and broadened our transatlantic collaborations. I actually thought that, as sea level rises and the ocean deepens, we have deepened our collaborations as well. But make no mistake, our ability to do precision altimetry over the decades and to implement Sentinel-6 now is possible only because of the vision and the contributions of many thousands of scientists, engineers, managers, and diplomats from both sides of the Atlantic and from academia, government, and industry. Each and every one of those thousands of contributors deserves to have their name associated with this mission, and I personally salute you all. Thank you, Administrator Bridenstine. Thank you, Joseph, Thomas, Alain, Mercedes, and Steve for your kind words and your strong support over the years and the decades. Speaking to you and to everyone who contributed to the successful development of Sentinel-6, it's been a privilege to work with you, to learn from you, and to be able to call you friends. The entire world is expecting great things from Sentinel-6, and I know that you will deliver. Go Sentinel-6.
what I'm going to do is close off this really exciting event. Of course, today is all about Earth science, the love of our planet, and our desire to understand it. It's about international partnership and friendship. And it's about, quote, a unique personality. Thank you, Jim, Breinstein, and your team. What's really important to me is whether we're in front of cameras, whether in a room by ourselves at 8 o'clock at night, you've always been consistent about your support and of Earth science and of partnerships. And so I just really want to thank you for being here today. In fact, I want to thank you for actually recommending as the first person that we should really consider naming a mission for Mike. And you will always have that credit from where I'm at. You were the first one who brought that up. I want to thank the representatives from centers, Dennis Sandrusik, the Center Director at Goddard, representatives from JPL, of course, where a lot of this work will happen. There's still a lot of work to do with Sentinel-6, Michael Freilich. And I want to thank the international partners who have spoken here, who already mentioned their name. I want to thank all the colleagues who took time out of their day. You're all busy, I know, to celebrate with us, both Mike, but also this important event. And I want to thank Mike and Shoshana for being here to celebrate with us. November 10th, 2020, I want to see all of you again, Mike and everybody else. We're going to be in Vandenberg together, and we're going to look at this rocket that stands there with that spacecraft on top of it, ready to launch, having the hopes and work of all these thousands of colleagues, international colleagues, on top of there, ready to launch. I'm going to be very nervous, as will be Josef. It's not because we don't trust the amazing industry that has over many years successfully put these spacecraft up. It's when that moment occurs, where we lift out of away from this planet. It's a historic moment anytime, a moment that you love every time. I know I sat next to you for one of them, and we've celebrated. And we're all going to be there, and we're going to shout. I'm going to tell you what I'm going to say, and I want to have you repeat after me before we close off. I'm going to say there, go Sentinel-6, Michael Freilich. Go Sentinel-6, Michael Freilich. Thank you so much.
A critical test for our commercial crew program, spacewalkers focus on upgrades aboard the space station and paying tribute to one of our great observatories. A few of the stories to tell you about this week at NASA.
Ignition, liftoff, center 5, aim high.
We teamed with SpaceX on January 19th to test the launch escape system of the company's Crew Dragon spacecraft and Falcon 9 rocket. The system protects astronauts in the unlikely event of an emergency during launch. This was the final major flight test before crew flights to the International Space Station. The International Space Station's Expedition 61 crew conducted a pair of spacewalks to complete some important upgrades. On January 20th, our Jessica Meir and Christina Cook installed the final new lithium-ion battery as part of an overall upgrade to the station's power system that began in January 2017. 5 days later, our Andrew Morgan and Issa's Luca Parmitano finished repairs of a cosmic ray detector. After 16 years of amazing discoveries, the mission of our Spitzer Space Telescope will soon end. Its infrared scans of the cosmos have discovered several Earth-sized exoplanets and produced some breathtaking images. Engineers will decommission the spacecraft on January 30th. Our OSIRIS-REx spacecraft completed the closest science observations to date of a sample site during a flyover only 0.4 of a mile above Nightingale, the mission's primary sample site on asteroid Bennu. High-resolution images collected during the flyover will help the spacecraft avoid hazards during sample collection later this year.
Keep your eyes on the prize. Hold on.
Our annual commemoration of Martin Luther King Jr. included a program at our headquarters featuring words from former astronaut Scott Altman and Janice Mathis Esquire, Executive Director of the National Council of Negro Women. And from space, astronauts Jessica Meir and Christina Cook had these words of tribute to Dr. King at the conclusion of their January 20th spacewalk.
And one has a spectacular view that we have today, looking down on our one common home, planet Earth. These words resonate loudly. It's so meaningful for us today to be out here on the day we honor Martin Luther King Jr., who paved the way not only for us, for so many that have a dream.
That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.
station, this is Houston. Are you ready for the event?
Houston, this is Station. I'm ready.
ABC News, this is Mission Control Houston. Please call station for a voice check.
Station, this is ABC News. David Shirley, how do you hear it?
Good morning, David. I hear you loud and clear. Welcome on board the International Space Station.
Always a pleasure to speak with you, Christina, especially now you're a record setter. Getting ready. You thinking you were going to set a bunch of records? At least a couple. How does it feel?
You know, that's right. I didn't necessarily know what this mission was going to turn into when I launched, but I think one of the things about the astronaut corps is that we are taught to be adaptable and to be ready for anything and any mission that comes our way. And one thing I like to say to my friends who also were surprised when I had my mission extended was that when we started this job, fulfilling our dreams and getting to contribute to this program, none of us knew what our space destiny was going to be. And it turns out that for me, I got the opportunity to live and work on the International Space Station for almost 11 months. So that's been my privilege and my honor.
It was a big deal, the first all-woman spacewalk. Now, you've done a couple of them. In fact, the last one it ran for, almost 8 hours, and a lot of us watched it, but didn't get quite the same attention. Can you add some perspective of the first one being such a big deal, and the work was the same on the third one?
You know, that's right. I think it speaks to a lot of things. First of all, on that first all-female spacewalk that Jessica and I did, we were truly overwhelmed by the amount of support, by the amount of enthusiasm, and by the amount of people that reached out to let us know that it did serve as inspiration to them. So that was wonderful. It was wonderful to follow in the footsteps of those that paved the way before us and to let them know that through their efforts in the past, we were able to achieve our dreams and to take that next step. And I think it is wonderful, actually, that the third time around, it's already become commonplace. We recognize now that we're doing the job the same as any of our colleagues, and we're all excelling. We all are held to the same standards, very high standards, and it really just is kind of transparent, and that's how we want it to be going forward.
Let's talk a little bit about your record. So you are now the longest duration flight for an American woman in space. Part of the reason is that the American capsules by SpaceX and Boeing were not ready. We expected you to come down in one of those. More broadly, talk about what you think, where we are in that program. It looks like they're about ready and you're just going to miss it.
You know, that's right. I was hoping to get a chance to welcome some of my friends on board on those commercial vehicles, but it didn't turn out that way. And I was never planned myself to return on one of those vehicles. I was always trained on Soyuz for Soyuz return. I will say that it's been very exciting. In my time here, I've seen a lot of the really big milestones of those programs take place. The Boeing Starliner OFT mission, the launch aborts and pad abort tests for the various commercial vehicles, and also talking with my colleagues and learning just how close they are in their flight training and how ready they are to be test pilots for these new vehicles. It's a really exciting time.
What's been the hardest thing going more than 300 days in the station for you?
Yeah, that's a great question, and I think about that a lot. I do find that every day is an opportunity to bring my best, and I think one of the challenges being here long term is that the engineers on the ground and our flight operations team on the ground has made living and working here so easy and almost comfortable that I think the challenge is actually remaining vigilant, remembering that you really are surrounded by a hostile environment and that a single emergency or a single, set of string of failures could bring you into a chance where you have to exercise some of that really important training that we had on the ground, which in my case was over 10 months ago. So remaining vigilant for handling any kind of emergency that comes up is important, but also remaining vigilant mentally and remembering how special it is here. It can become commonplace floating around, looking at Earth from above and things like that. So just remembering how special it is here and focusing on everything that I have and not necessarily the things that aren't in my environment, the things on Earth, has really been the thing that I focused on the most as my mission endured and got a little bit towards the end.
talked to Scott Kelly before he went up and during his flight and when he came back. He was a guinea pig. He went up for a long-duration flight. Maybe you weren't planned to be a guinea pig, but you are now. What contribution do you think you may have made to science as a scientist?
You know, just by virtue of being here and all of the physiological and human research studies that I'm a part of, it's pushing the envelope on what we can say is normal for a long-duration mission. Obviously, Scott Kelly's mission gave us one data point in that, and now this hopefully will expand that by a second data point so that we can look at what sort of stayed the same, what's different, and then in addition, the differences between women and men in that capacity, because obviously we all want to be a part of going forward for the longer duration missions that this research actually informs. So I hope that in participating in all those studies, I help the scientists be able to design missions better for astronauts in the future, going to Mars, living for a long time on the moon, or, you know, in the Lunar Gateway. So it's been my honor to kind of pave the way for those future missions.
You've got at least a couple of more weeks up there. Are you already thinking about the fact that you want to come back to Space Station?
You know, it's hard not to think about what is the future because, of course, as I think about leaving in about 10 days, I think, will I ever be back here? You know, am I saying goodbye for the last time, or will I get to come back? And if so, how will it have changed? So, yes, I'm definitely thinking about those kinds of things. It feels too soon, even though it has been a long time for me to not be contributing up here, you know, as an astronaut in the microgravity environment as I've been training to do, and I have had such practice in now. So with a little bit of luck, I will get a chance to do a future mission.
All right, we're going to try a lightning round. With the satellite delay, it's kind of difficult, but here we go with the lightning round. The smell you've missed the most?
The fall and the forest.
The food you've missed the most?
Chips and salsa.
Well, that you should be able to get pretty easy on station.
You would think that, but I'm going to have to tell you about the chips thing since you mentioned that. Anything flaky, actually, we can't have up here because as soon as you would bite into it, it would just go everywhere. So things like texture and things that are crunchy, we don't really have up here, so that's what I've been craving.
The activity you've missed the most? You spent a lot of time in ice and snow.
The activity I've missed the most up here is surfing.
And what has your husband said he's missed the most about you?
I think I would say help around the house. I like to do a lot of home maintenance, so he's been solo running those tasks for a while.
And the last one is Scott Kelly wanted to get and jumped into a swimming pool. The first thing you will do when you're completely free to do anything on Earth again?
Go swimming in the Gulf of Mexico.
All right, and I should ask before we say goodbye, gravity, do you miss it? Is it a good thing?
I only miss it when I just really want to put things down occasionally, but I've gotten used to Velcro and taping things down instead, so I don't really miss it. It's a lot more fun without it.
Christina Cook, thank you very much. Congratulations on the duration and for all the spacewalks and everything else. Great to see you. And safe travels home. We love to see you on the planet.
Thanks so much, David. Great speaking with you again, and I hope to see you back on the planet as well.
Station, this is Houston ACR. That concludes the ABC News portion of the event. Please stand by for a voice check from Associated Press.
Station, this is the Associated Press. How do you hear me?
Hello, the International Space Station has you loud and clear.
Christina, greetings from the AP at the Kennedy Space Center. By my count, this is Space Day 319 for you. And from down here, it seems as though your triple all-female spacewalks were the high point of your record-breaking mission. And I'm wondering, is that so? And how do you view the all-female spacewalks in the big scheme of things, and also from a personal standpoint?
Gosh, you know, I didn't know that was my day count, but that does kind of seem like a lot of days when you put it that way. And it is so difficult to pick the highlight, but I think you nailed it. I think that the opportunity to do the first all-female spacewalk with Jessica Meir, who is not only my coworker and colleague, but a dear friend, was a really special opportunity. I think that she and I both really appreciated and loved that it could serve as inspiration for future space explorers. We both drew a lot of inspiration from seeing people that were reflections of ourselves as we were growing up and developing our dreams to become astronauts. So to recognize that maybe we could pay that forward and serve the same for those that are up and coming was just such a highlight of that moment. I think in the greater scheme of things, it shows that we are committed right now to go for all and by all into our future space exploration. And that currently includes going back to the moon. We'll be going back to bringing the first woman to walk on the moon and the next man, and that's a really exciting time, recognizing that not leaving anyone's contributions, not leaving a single innovative idea on the table, and taking all of that from anyone who's has a dream, who's willing to contribute. It's just such an exciting time to be a part of this program.
Well, I know your astronaut class was half women and half men, but the astronaut corps still has a long way to go before becoming 50-50. How long do you think it's going to be before half the astronaut corps and half the station crew are comprised of women at any given time? And should that be a pressing goal for NASA?
You know, I do think that diversity is important, and I think it is something worth fighting for and something worth, you know, placing in a level of importance. As I could never say how long it's going to take, but I know that we are really looking forward to the coming years. We have a new astronaut selection period coming up, and recognizing that as that pipeline of women in STEM and other underrepresented folks in the STEM fields grows, we hope to then capitalize on that and bring that innovation and talent into the astronaut corps.
What surprised you most about yourself during the past 11 months in orbit?
You know, I think one of the biggest surprises is how the human body, both the mind and the physical body, can adapt to microgravity and adapt to spaceflight. When I first got here, everything seemed completely foreign. It was almost like I had to relearn just how to do the very basic things in life. And now I can't even imagine it any other way. I don't even really realize that I'm floating anymore. I have a lot of ability to orient myself despite the fact that I don't have gravity feeding my balance system like on Earth, and to see the human body adapt to that, to see the change in the fluids. You know, our bodies adapt to the lack of gravity, which normally pulls our bodily fluids down by changing around our, you know, the amount of volume and even in our bloodstream and things like that. So to watch that adaptation happen has been such an amazing surprise, and to sort of feel at the end of 10.5 months like I really have become adapted to the microgravity environment has been pretty neat.
How much longer do you think you could stay up there from both the mental and physical point of view, and do you wish you were staying even longer?
It's funny because I miss my friends and family dearly, and I would say if they could visit here, I would continue staying for a very long time. I absolutely love the work that I get to do here, and as I mentioned, I feel very adapted to life up here. So from my point of view, I would love to continue my mission and, you know, like I've said, to continue contributing to the program and to the research. But I do feel like it's been a long time since I've seen my friends and family. So for their sake, I think that it's probably time to head home.
What was the hardest thing you gave up when you rocketed into space last March? Obviously your husband and other family and friends, but besides that, what did you feel that you've given up that you really can't wait to get back to, or just something that's been a hardship, sacrifice, if you will?
You know, you named the things that I actually would say fall into that category. My husband and my family are the things that I really miss. Other than that, I have found that I really don't miss very much. The truth is, I know that all those things are waiting for me on the ground. And then during my time here, I've just really stayed focused on the things that I have that I may never have again, as opposed to the things that I don't have. And that really keeps me positive and keeps me focused and really in a very happy kind of frame of mind up here. And it's a very fulfilling job, and I think that that personal fulfillment and that meaning to every day is the most important thing that you can ask for. And since I have that, I really don't miss too much on Earth.
Well, along those same lines, what was the hardest thing to adapt to in space, or to, as you were saying, to relearn to do things? What in particular was especially difficult, and was it more mental or physical in the challenge?
You know, I think just the kind of day-to-day aspects of moving around and being efficient in microgravity. Obviously, without gravity, things can just float away in any direction. So for someone like me that finds it a challenge to not lose my keys even, you know, on the Earth, up here I find that it's very easy to lose things. They can float away without you even noticing. So little things like that. I jokingly say, what's one thing I miss about gravity? And I would say it's the ability to put things down, because I really miss being able to just set things down on a table and not have them float away. But like I mentioned, I also have gotten used to using Velcro and tape when required. So I hope that when I go back to Earth, I don't accidentally drop things, especially when I'm handing them to people, because I'm not used to actually doing that with Gravity Vector.
So I have to ask, what food do you have a penchant for? What are you craving as soon as you get back, and what activity? I recall how Scott Kelly got home and jumped straight into a swimming pool. I don't know if you have any plans for something like that.
Well, as for food, because a lot of our food here is rehydrated, and it's kind of it doesn't have a lot of texture, because things that are crunchy would just float away as soon as you got any crumbs. So I really actually miss chips and salsa the most. Of course, I miss fresh fruit as well, but we have had some of that on our cargo vehicles. So it's interesting. I haven't had chips in about 10.5 months, but I have had a fresh apple. And in terms of my first activity, hands down, it's going to be going for a swim on the Gulf of Mexico. I do live next to the ocean there, and either a swim or a walk on the beach or going surfing are high on my list.
Has Scott offered you any advice about what to expect when you get back from a physical point of view, or even how, you know, during the mission over these past several months?
Yes, both he and Peggy Whitson have both been really helpful. I talked to both of them before I launched, when we knew it was a possibility, and then even since then I've called them, exchanged emails with them. Scott even reached out just recently to kind of outline all the things that he experienced both right before leaving and after returning. So they have been really, really helpful, and it's a great reminder to keep mentoring. I do hope that as soon as possible the record is broken again, because that means we're continuing to push the envelope, and when that happens, I hope to mentor that person just as I've been mentored.
Well, I have to know, tomorrow is your birthday. Happy birthday in advance. How are you going to be celebrating?
Thank you very much. Yes, it is. And actually, one of my favorite things to do is play board games, which is a little bit challenging here. But I did bring a travel version of a board game up, and it's been tough to find time to play it. So my crewmates have promised me that we're going to play board games after dinner tomorrow for my birthday.
Well, I have to ask, what game is it?
We'll be playing Scrabble if everything goes well.
Well, I hope they let you win. I imagine holidays were tough to miss while you were up in space. Did you have to miss some big events or milestones over the past 11 months? And probably would that have been some of the tougher mental challenges of the mission?
It is true that when you take on a mission like this, you have to accept and recognize that life moves on without you on the Earth, and that big things are going to happen. Things like my mom and my family on that side moved. They completely moved to a new part of the country. So that'll be fun to see their new place. The holidays, we are so lucky because we're able to spend those holidays virtually with our family. We have video conferencing on special occasions. So I've been able to sort of feel like I was a part of the family, watching my nieces and nephews open Christmas presents and things like that. So that was really special. And of course, we recognize that it's so special to spend that holiday in space as well. So that kind of takes any sting off of it, missing your family. But I certainly can't wait for my next anniversary at home, my next Christmas holiday at home, and to spend my husband's birthday with him and things like that.
Well, you know, today, January 28th, is always a solemn day for the space community. I'm wondering if the crew will be doing anything today to honor the Challenger astronauts.
Yes, today being, I believe it's the 34th anniversary of the Challenger accident, it's definitely something that we all remember on a day like this. And in addition, many NASA centers, including Johnson Space Center, where all the astronauts are headquartered, has a day of remembrance. This year is going to be on January 30th. And on that day, we take a moment to symbolically recognize those that have made that sacrifice. As astronauts, we do special things like organize a T-38 formation flyover of a tree grove where trees are planted in remembrance. So we certainly do pay homage to those that gave a sacrifice in advance and many years ago.
Well, Christine, it's been a pleasure. I'm hoping to see you launch on a Dragon Starliner or maybe go into the moon. Safe travels and Godspeed.
Thank you so much, and I really appreciate your interest. It's been great speaking with you today.
Station, this is Houston ACR. That concludes our event as we count down to 20 continuous years of humans living and working on the International Space Station.
Thank you to all the participants from ABC News and Associated Press. Station, we are now resuming operational audio communications.
This year, 5 new missions are taking off to investigate our home planet. From coast to coast, these missions will take a closer look at everything from sea level rise to snowstorms, all based right here in the United States. About 200 miles off the coast of San Francisco, the Sub-Mesoscale Ocean Dynamics Experiment, or S-MODE, will use measurements from a research vessel and 3 planes, a King Air, a Gulfstream, and a Twin Otter, to look at how swirling ocean eddies affect the movement of heat between the ocean and the atmosphere. Autonomous wave gliders and ocean gliders will dive below the surface of the water to get a full picture of the ocean and atmosphere. Together, the mission will collect data about temperature, salinity, and ocean velocity to get a better understanding of how small eddies affect the upper ocean. Traveling inland to the Midwest, the summer months can bring intense thunderstorms. Strong winds formed by these storms can overshoot the troposphere and reach higher in Earth's atmosphere, injecting pollutants into the stratosphere, which can affect the ozone layer. Using an ER-2 plane flying up to 70,000 feet, the Dynamics and Chemistry of the Summer Stratosphere, or DCOTS mission, will investigate how the pollutants reach the stratosphere and how their impact could change in the future. Farther south, the Mississippi River Delta is sinking as sea levels continue to rise globally. The Delta X mission, no acronyms here, will combine measurements from 2 planes, a King Air and a Gulfstream, with measurements taken on the ground and in the water to study how and where soil is naturally transported and deposited by water. This can help researchers better understand how the coastal regions will be affected by rising sea levels. On the east coast of the United States, the Aerosol Cloud Meteorology Interactions over the Western Atlantic Experiment, or ACTIVATE mission, will look at how clouds in the marine boundary layer, roughly the 2 kilometers above the ocean, affect the water cycle. These cloud systems cover large stretches of the ocean and are not well represented in climate models. ACTIVATE will use 2 planes, a Falcon and a King Air, to take measurements remotely and in situ, including releasing dropsondes through the clouds. Flying the same corridor, the investigation of microphysics and precipitation for Atlantic coast threatening snowstorms, or IMPACTS mission, will use measurements on the ground, scientific balloons, and 2 planes, the ER-2 and the P-3, to measure snowstorms at all altitudes. IMPACTS is looking closely at the intense bands of snow that form inside clouds to improve forecasting of snowstorms in the future. Stay tuned for more as these 5 missions take off.
MSOLO stands for Mass Spectrometer Observing Lunar Operations. We took an off-the-shelf mass spectrometer and worked with Enphicon to ruggedize the design to withstand the harshness of space. We bolstered the glass instrument detector, redesigned the avionics boards for better heat flow and increased radiation tolerance, and applied other standard spaceflight practices into the design. On the lunar surface, MSOLO can measure resources like water, crucial to deep space exploration, and it can measure the gases coming off a lander during touchdown. This is important so we know what is truly coming from the moon and what we brought with us. Being able to identify the lander signature will ensure we are only measuring what was already on the lunar surface. MSOLO will be sent to the moon as part of the Commercial Lunar Payload Services contract. Essentially, commercial companies are building lunar landers, and technology like ours is hitching a ride down to the surface. Not only will MSOLO help us learn more about the moon and ultimately change the way we explore our solar system, but the new rugged design we helped create is changing things down here on Earth too. By modifying an off-the-shelf mass spectrometer, NASA helped Enphicon identify ways they could improve their product that would also help universities and other researchers using their equipment in harsh environments here on Earth. In Costa Rica, investigators are flying a commercial mass spectrometer on drones over safely detecting what gases are being emitted. Information from volcanic plumes provides insight into what is happening inside the volcano, alerting researchers if a major eruption is imminent. We are proud of MSOLO's capabilities in space and right here on Earth. And now we're headed to the moon. From Kennedy Space Center, I'm Patricia Valendia.
When it opens its eyes to our universe in the mid-2020s, WFIRST, the Wide Field Infrared Survey Telescope, will capture images unlike any satellite before it. WFIRST will have the same image resolution as Hubble, but will cover an area 100 times larger. WFIRST will also view the sky in carefully selected wavelengths of infrared light, which will allow it to see through obscuring dust, to reveal hidden stars, and watch the growth of galaxies over the last 10 billion years. To see what the sky will look like to WFIRST, scientists use special processing techniques to create simulated images. In this case, they began with a Hubble mosaic of Andromeda, one of the closest galaxies to our own. Released in 2015, this mosaic was created out of over 400 individual Hubble images and took more than 3 years. Because of its enormous coverage, WFIRST will be able to create a similar mosaic with just 2 images, each taking about